Welcome to lesson 26, part 4 on the double data type in Java. I'm going to do some examples of assigning or initializing doubles with other primitive types, as well as assigning doubles to other primitive types. We will see what we can and cannot do. I'll be using, as you can see here, jshell for this. If you're unfamiliar with jshell, you're welcome to look at my playlist of video tutorials on this. Here I assign integer literal. In actual fact, what I do is I take an integer literal of 9, I cast it to a byte, and then the byte is assigned to a variable d1 of type double. I'm doing exactly the same thing, but I'm casting it to a type short, the integer literal, and then assigning it to a double named d2. In this case, the integer literal is already default an integer, so I don't need to cast it to a short, even though it's smaller, to get the right type. It is an integer and I'm assigning it to a double. And in this case I'm assigning a literal of type long, as you can see the suffix l, to a double of named d4. What do you guys think this one's what's gonna happen here? I've got a character here, a char value, char value, and I'm assigning it to a double. And that's fine, it gives me 98, because remember that a character is of type int, and its corresponding int is 98, so 98 is cast to a double 98.0. Yeah, I'm assigning integer value 127 to type byte, and there's a special caching value which we'll touch later, and that's why I don't need to cast that on, and it fits. And then I am now assigning the byte value b1 to a double. I'm assigning a variable L1 of type long to long's max value, which is a constant field in the class long. And yeah, we're taking that long's max value, which this variable here, which is now here, and I'm assigning to a double D7, and it's outputting its scientific notation over here. And that is the integers min value using the integer class constant min value. And there I'm assigning it to the double. I could also do this. I could actually say I want to cast it to a double and then assign it, although it's not necessary to do it this way, as you can see, because I did it here without casting. Yeah, I took the binary format of an integer, the value of 9, and I assigned it to a double. Yeah, I took the hex value. If you recall this, when it starts with a 0, is not a hex, it's an octal value, octal 11, which corresponds to a 9, and I've assigned it to a double. And yeah, I took hexadecimal value, 0x stands for hexadecimal format, and I've assigned a double, which is a 9. So in the last 3 cases, in these 3, I'm just going to show them all that I've done so far. You can see here I've assigned doubles and so on. I've assigned 0 to a double D12. I've assigned true to a Boolean value. What do you think is going to happen in this case? If I try and assign the Boolean primitive type to D12, which is a double, it's giving me an incompatible error. What if I try this? The Boolean literal is giving me the same problem. Let's try and force it by casting. Cast it to a, let's try and cast, let's say B1, which is a Boolean, to D12, which is a double, and it's still giving me an incompatible issue. So as from this you can see you cannot assign a Boolean to a double or any other primitive type in this case. Let's just try an integer. I'm going to say int i3, and I'm going to try even cast it, force it, in other words, the boolean to, and it's giving me still the same issue. So you cannot assign a boolean to a double or any other primitive type, as boolean is a special primitive type that only allows two special values, which is true and false, even if you try and cast it. Okay, yeah, I'm assigning float's max value to a float with the name of f1, a variable f1. Okay, I'm assigning the float to a double, the max value of float to a double, and that is fine. And just as another example, I'm assigning a float literal to a double, and that's fine. And yeah, I'm going to use the value of method of the float class, and I'm going to use each method to take a string, which we will cover in later lessons. But what I'm doing here is I'm actually using the floats class method, static method value of, passing it the string of 56.6 of f type float. That converts it to a float, returns a float value, and that float value I'm assigning to a double, and that is fine. So from the above examples, these examples here, we can see that you can assign any float to a double, because a float, if you recall, is 32-bit and a double is 64-bit. It's bigger. It's the bigger one of the floating point numbers in Java. Yeah, I'm assigning the max value of a double using the wrapper class doubles constant value to a primitive type double named E16, and you can see I've got a video on its max value, but that is totally legal. It works. And this one, you cannot, as you can see, it's approximate 1.797 to the E308. It's doubles max value, and yeah, I'm doing it 1.8 E308, which is larger. And so you can't assign floating point number is too large to fit in double. It's above its max value. And I say approximately because we know that Java uses a floating point number, uses the IEEE 754 standard format, and if you recall, I'm saying it's a floating point and not a fixed point, so there are exceptions which you guys can go look into, or I'll touch on it in a future video. And this is double's min value, which is approximate 4.9 e to the negative 324. And this number here is smaller than that number. So if you look at this number here, it's negative 324, and this one is, its min value is negative 3. That's 325, and that's 324. So it's smaller, this one. And as you can see, it also gives me a problem. So you cannot assign a value to a double that's approximately smaller than the minimum allowable value in the, which is an example I'm showing here. I say approximately because we know that Java, using floating point numbers, uses the IEEE 754 standard format, and it's not a fixed point but a floating point number. So there are different cases there where you might think it violates the rule or something. Okay. I'm getting an error here when I try and take remember it's 1.0 is a double literal, so I'm trying to assign a double to a byte, and it's telling me there could be possible loss of conversion, so it's not allowing it. But if I do this and I say, okay, I'm aware that there might be a loss because a double is bigger than a byte, but do it anyway. So I cast the double to a byte, and that will work fine because I'm telling Java it's okay, go ahead and cast it anyway, even though I know it's a byte, but I know it's within the range, so I cast it. Yeah, I'm just using the suffix, but I'm using a short in this case, and I'm getting the same issue. But if I say short and I say cast it anyway, and there the double 1.0 is now a short value. It's assigned 1 to it. Same problem with the int, because the int is 32 value and a double is a floating point 64-bit. It's complaining that there might be loss, but we know that 1.0 will fit because it's a 1, so we're going to try and cast it. And as you can see, it works fine. I'm using the suffix again. So we know the double, and I'm trying to assign it to long, and it's complaining possible loss of conversion, because even even though they're both 64, remember the one, the double is using scientific notation, so it can have longer numbers, bigger numbers or smaller numbers than the long, which is an integer type. So same problem. So I tell it, let's, I know it fits, so cast it for me, please. It must be a 0, not a O. And 100% along is now a 1, value of 1 there. Yeah, I'm asking to pass a double literal value of 98.0 to a char. What will happen here? And as you can see, same issue, it's loss of conversion, because remember, character, a char is actually int values that are mapped to different characters. But if I try and force it, what will happen then? Let's say Java. I know 98 is small enough to fit in a char value. Go ahead and do it anyway. And as you can see, its equivalent value of 98 int is converted to 98, which character is a B. And yeah, I'm trying to assign 99.0D, which is a double literal, to a float, and a double we know is a 64-bit floating point number, where a float is a 32-bit, so it's too big, so it doesn't do it, because there might be a possible loss when you do a conversion. Let's say lossy conversion, double to float. So what happens if I do this? Go ahead and do it anyway, because I know 99.0 is well in the range of the float. And then it assigns the float, the value of 99, it converts it to a float now, and it assigns the value there. What about this case? And we know we must cast a double, so let's cast it to a boolean. And let's say 0.0, which is the default. We know 0.0 without any suffix would give me a default type double literal, and I'm casting it to a boolean. What do you think is going to happen here? Same as I mentioned before, you cannot, and that is because the boolean type only allows two types, which is true and false. Do one more here. D19, let's say we assign it a value of 0.0 to D19. The int value, and we're assigning D19, which is a double, we are assigning that the reference D19 of type double, which is 0.0 to I3, which is int, and it's same as the others. Double is too big to fit, so but we can cast it, I'm sure. Let's try and cast it to a double, to an int. The double to an int. So D19, we cast it to an int. Complain, oh, I didn't create the int value because that one gave me an error there. So let's just fix that. I have to tell it it's an int value. And there, that's fine if I cast it. So from this we can see that you cannot assign a double to any primitive type except for double without casting. Okay, and that's due to the fact that double is larger than other types, so there is a possibility of loss of precision when converting from a larger to a smaller type. So see cast as, in this case, I know there may be a loss, but go ahead and do it anyway. But note that you cannot cast a double to a boolean, as a boolean only holds two special values, which is a true and false. There are other languages, or maybe other languages, where they treat the boolean as 0 and 1 as true and false, but that's not the case in Java. We have reached the end of this lesson. We saw that we can assign an integer type to a double. We can also assign a float to a double. We also saw that the boolean type is a special type and cannot be assigned to a double even if we try to cast it. We also noted that we need to cast a double to any of the integer primitive types. I hope you've enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I've also got a Facebook page related to this channel. You are welcome to join my adventure channel where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.